To understand the nature of addition of numbers, it's easiest to use the number line to see what's going on when two numbers are added. So let's start with, let's see, let's add 3 plus 4. So what's actually happening is we're taking some number 3, which is 3 units away from 0 on the number line, and then we're adding 4, which means that we want to go in the direction to the right, or in the positive direction. Okay, so addition is in the positive direction, or when you're adding a positive number to a positive number. So if I start at 3 and add 4, that means I want to go 4 more places or 4 more spaces to the right. I end up at 3, 4, 5, 6, 7. And so 3 plus 4 equals 7. Okay, so you didn't need a number line to see that, but what if I had said, let's add 3 plus a negative 4? So I'm going to add a negative 4 to 3. Well, that would be a different direction because the 3 tells me to jump right onto 3. That part's the same. Add says to go in the positive direction, but the minus right here tells me to turn around and go in the direction of negative numbers. So I want to go in the negative direction. Because adding integers is different than adding whole numbers. Adding whole numbers, we're dealing with all positive numbers, like having 5 marbles in your bag and 3 marbles in your hand. If you put the 3, add the 3 to the bag, you have 8 marbles. But dealing with integers, we're dealing with negatives. And so dealing with negative numbers sometimes can be a little bit more difficult to imagine. So in this case, 3 plus minus 4 tells us to start at 3 again, heading in the right direction, right? Heading in the positive direction. But minus says turn around and bounce those 4 times in the negative direction, and I end up at negative 1. So it's possible to do some pretty complicated additions and subtractions, or excuse me, additions of integers on the number line. Let's say I want to start with a negative 4, and I'm going to add to that a positive 5, and then add to that a negative 8, and then add a negative 2, and then add a positive 4. So I may regret choosing those number values, but let's give me enough room to work in just in case it gets really big. So I'm going to put my 0 in the center and start at the very beginning. So negative 4, so negative 4 tells me to go from 0, go 4 units in the opposite or negative direction. So I'm going to start here at negative 4 and then set myself up to be going in the right direction. Okay, so I'm at negative 4, ready to go in the direction of positives, and positive tells me I'm headed the right way. 5 tells me to bounce 4 times from there. So that's 1, 2, 3, 4, 5. Excuse me, 5 times from there. And I end up at a positive 1, ready to go in the right direction again. Add tells me I'm still going perfectly well in the right direction. Minus says I need to turn around. So I'm going to add a negative number, means I'm going to turn around and add the 8. And then I want to bounce 8 times. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to mark where I am. Negative 4, negative 5, negative 6, negative 7. And then I'm going to get all ready to go in the right direction. So I finished with my 8, headed in the right direction. Plus sign, it's addition, which means I'm headed the right way. But I have another turnaround. Turnaround says, nope, I want you to add 2, but I want you to go in the opposite direction. So I'm going to add 2 in the opposite direction, which puts me at negative 9. And now ready to go again in the right direction, because this is addition. 4 says keep going that direction. 1, 2, 3, 4. And so I end up at, well, I'm not quite sure where I end up. Let's count. So from -9 to -7, so 7, -6, -5. I'm at -5. And that's true because this is -4. But I just wanted to be more specifically clear. So this equals -5 altogether. Now there are some shortcuts you can do with it, but sometimes it's just helpful to picture yourself on a number line and imagine, okay, I'm adding an opposite, so I got to go the opposite direction, where would I be? And then I'm adding a positive, so I'm going to go in the positive direction, where would I be? And then going back and forth that way. Sometimes it's easier to see it on a number line. All right, so let's do a couple of examples. I'm going to add -4, that's the opposite of 4, to 2. Now I can picture in my brain that if I start at -4 and then I add a +2, that means I'm going to go in the positive direction 2 bounces, which will put me at -2. So let me put that on the number line real quick just to make it clearest. So if I start at -4 and I want to go in the positive direction, 2 bounces from there puts me at -2. Let's do one more. I have 8 plus the opposite of 11. So I need a paren to contain that. So that means if I start at 8 on the number line, because it's addition, I'm expecting to go in the positive direction, but I have to turn around and go backward 11. So I'm going to add a backward or an opposite 11 to 8. That means I'm going to go past 0 and I'm going to get into the negative numbers. So let's put that on the number line just to see it. I think you probably might already even know the answer. If I go backward, I'm going to eat up 8 of them, or excuse me, I'm going to eat up 8 of these 11 bounces, getting to 0, and I only have 3 left. So I'll be at -3. But let's go ahead and number line this. So if this is 0, all right, I start at a +8, and because it's addition, I'm expecting to go in the positive direction, but I'm going to bounce in the opposite direction because I'm adding an opposite 11. That means I have to turn around and go backward. So if I bounce 8 times, I'm going to end up at 0. So 8 of my bounces will take me to 0, and I only have 8, 9, 10, 11. I only have 3 bounces left. That puts me at -3. So that's how I get a negative or an opposite of 3 for my answer there. Now, one of the things that new math students hate, and you'll probably hate it for years, and I hate to use the H word when I'm talking about anything mathy, but properties of addition and multiplication and such, we have to get under our belts. So we just have to do it. The sooner you do it, the better. I'll break them down for you, and hopefully you'll make some note cards or something, and you'll just really work hard to get them under your belt, because they're going to annoy you until you make sense of them. So let's start with the properties. Well, let me just title them first. Properties, properties of addition. So properties of addition, and there are properties of multiplication and properties of division, and there are properties all the way through your math experience, but these fundamental properties show up a lot. So it really serves you well to kind of get an understanding under your belt at this stage of the game. So let's start with the commutative property. Let's try that again. Commutative property, and it's actually, I spelled it wrong, it's commutative property. And what that means is that you can switch things around. So commutative property means that if it works in that direction, it'll work in this direction as well. So not all numbers have, or not all operations have a commutative property that go with them, but addition does. If I'm adding 3 plus 2, well, that equals 5. And the question is, addition is commutative if I switch the 2 and 3 around, right? So I just switch these and add 2 plus 3 instead. Does that equal 5? And indeed it does. And the property is written this way. A plus B equals B plus A. And what that means is if I take A and add B to it, I'll get the same value as taking B and adding A to it. And this works with positive and negative numbers. Let's look at an example of both. So positive numbers, if I were to take, well, let's use 3 plus, let's say, negative 2. 3 plus negative 2, well, that equals 3, turn around to 2, it's going to take me to 1. Okay, so the question then is, does negative 2 plus 3 also equal 1? Are they the same value? Well, if I start at negative 2 on the number line and I bounce forward 3 times, I end up at 1. So they are indeed commutative. They're commutative around the plus sign. That just means that you can do it in either direction. You can add negative 2 to 3, or you can add 3 to negative 2. Works in both directions. So another property of addition is the associative property. So this one is one of the really tough ones. Sometimes it can take a long time to really understand how this property works. So I'm going to use another story. I'm going to kind of tell a story using a word that sounds like associative. I'm going to use the word association. So an association is like a club. Okay, so an association of people is a group of people or a club of people. So suppose you and me belong to an association called the Bird Lovers Club. Okay, so that's our association. So I'm person number 1, and we get together and meet, and I bring along my best friend, person number 2. And you're person number 3, and you bring along your best friend, person number 4. And we're sitting around a table having our club meeting, and we're talking about all the birds we saw, and we're just having a great time. But a week later, we come together, and we sit around the exact same table, and everybody shows up. We sit around the exact same table, only this time I sit in the same place, but my best friend sits across from me. And then you sit here, and your best friend sits across from you. So my question is, when you come to your meeting the second week and you all sit and we all sit in separate chairs, do we stop being a club? Are we no longer an association? Well, of course we're an association. We sit together at different places, but we're still a group of bird lovers. And that's exactly what the associative property for addition is. It says that if you take 3 numbers, A plus B plus C, if you add A plus B first and then add C, you're going to get exactly the same value as if the same numbers came together and you add B plus C first and then add A. So that's the associative property, and let's look at it at work. 1 plus 2 plus 3 equals 1 plus 2 plus 3. And we can kind of tell intuitively that that's probably true. But let's do it this way. Let's put 1 plus 2 together first. So that's 3 plus 3. Yeah. On this side, we're going to put 2 plus 3 together first. So we get 1 plus 5. But are these the same thing? Because by changing the association up, by shaking up the members, did I change what it actually equals? And obviously I didn't, because 3 plus 3 is 6, and 1 plus 5 is also 6. So the associative property says that when an association, when a group of people get together, I didn't add new people in, it's the exact same people. All I did was rearrange who sits where. So instead of me and my best friend sitting here side by side one week and then sitting across the table the next week, right? It doesn't matter who you're next to. Excuse me, it doesn't matter who you're grouped with. It just matters that you're all there. So now we'll look at the identity property. So the identity property makes use of something called the identity element. And it basically says that if you do something using addition and what you get back is what you started with, then that's the identity property. So if you were talking about people, if I had me, person A, and I did something to me like put on makeup or something, what would I get? Well, A plus 0 equals A. If I get me back, because all I have is makeup on, I didn't change who I am, I just put makeup on, then if I get me back, then my identity hasn't changed in any way. And with addition, the identity element is 0. If you add 0 to any number, you just get that number right back. So the identity property says A plus 0 equals A. There's another way for that to be, though. It could say 0 plus A equals A. And in fact, there you go. I did something to A, and I got A back. That's called the identity property. The identity hasn't changed by adding 0. And the last property for us to look at would be the inverse property. And the inverse property is also going to show up a lot in your future. Inverse, in particular, in algebra has a very specific meaning. The inverse of anything is the thing that undoes it. So the inverse of something is the thing that undoes something. Okay, so not very mathy talk, but let's look and see an example. If I have some number like 2, and I add to that negative 2, well, 2 plus minus 2, that means I'm on the number line at 2, and I'm adding, but I have a turnaround because I'm adding the opposite, and I go 2 times back, I end up at 0. I actually undid 2. So 2 exists and negative 2 undid it, the answer being 0 or the value being 0. That is the inverse property. And inverses show up in a lot of different ways. So if you think about it as I'm looking for the thing that undoes it. Another way that you sometimes think of inverses is when it comes to fractions, and we'll see in the future how that's also true. The reciprocal is sometimes called the inverse of a fraction. All right, so I think this is a good time to do a few examples. So example 1, 7 plus negative 7 equals 0. And all I'm asked to do is identify the property. Well, let's see. I have a number that I added something to it that just undid it and took me back to 0, right? So this is the inverse property. All right. Example 2, let's look at negative 12 plus 0. So what property is this? Well, what do I get when I do that? I get myself back, right? I start with negative 12, I add something to it, and I end up with negative 12 back. That means I have the identity property. And let's do one more example. I bet you can guess what it's going to be, but let's just look at it anyway. I have 4 plus 8 equals 8 plus 4. Oh, I guess we had 2 more properties, so it's not so obvious. Okay, well, what did I do here? Well, these are equal to each other. In one case, I added 8 to 4, and in the other case, I added 4 to 8. All I did was switch them around. So this is the commutative property. And the only property left, the one I thought I was going to do just a second ago, is the associative property. So 2 plus 6 minus 1, oh, not minus 1, plus negative 1 equals 2 plus 6 plus negative 1. Okay, so first if I group the 2 plus 6 together and then add an opposite of 1, or I could add the opposite of 1 to 6 and then add 2 to everything, that would be the associative property.